Hello guys, welcome back to my YouTube channel. So today's daily LeetCode question is binary search tree to greater sum tree. Now what is a binary search tree? So a binary search tree is a tree where the all values less than the root node will be present in the left side. The all values greater than the root node will be present in the right side. And the both left subtree and right subtree again follows the same constraints to maintain a sorted order of the tree. Now let's look into the greater sum tree. So what is a greater sum tree? Greater sum tree is a tree where the node value will be node value plus the values which are greater than the row values sum. To the example part to understand this question. So let this be our given DSC. So you can see that all the values less than 4 are present in the left side of it. All the values that are greater than the root node are present to the right side of the tree. And the subtree follows the same rule again. You can see that here the zeroth value will be 0 plus the nodes which values are greater than 0. So all nodes are greater than 0. So the sum of all nodes will be 36. Again, you can see that if there is one node, so the value will be 1 plus the nodes which the values are greater than all the ones. So you can see that we don't need to include this, but we will include all these. And the cumulative sum of all these will be 35. So hence the value will be 36. So again, if you take a root 2, so 2 plus, we need not to include these, we need not to include these because the both node values are less than 2. So we have to get the sum of all these nodes and add it with the 2. Hence that is 33 will be 35. So we have to return a tree, the greater sum, which will somehow look like 36, 36, 35, 33, 30. So this will be half of our tree. So this applies to the same right subtree also. I hope you understand the question. Let's look at the intuition part. So what we can do is we can first get the sum of subtree. So binary search tree. So that is the total sum of the binary search tree. Ideally which is 0 plus 1 plus 2 plus 3 plus 4 5 plus 6 plus 7 plus 8. So the sum of all these nodes will be 36. Okay, the sum of all nodes will be 36. Okay. So here you can see that the zero when we have to again traversal using DFS, but this time we have to modify the values at the node. So we will be visiting the left node first and modifying its value with 0 plus 36. Okay guys. So this is the first intuition we gonna do. And again we will be visiting this node. So we will be traversing DFS. DFS is nothing but in-order traversal. In-order traversal follows left, root, and right. So this will be our first approach. So if we travel in-order traversal, then we can visit each and every node and modify its value with the total sum. And again subtract it with the total sum. After modifying the value, we have to subtract 36 minus 0, which will remain 36 only. Then we will visit 1 and we will modify its value. So 1 value will be 36. So before visiting the next node, we have to modify value 36 minus 1, which will be 35. So after visiting 2, we have to modify its value. So its value will be 35, and before visiting another node, we have to modify the total sum. So which will be 35 minus total sum, which will be 33. And again we will visit 3, and the value of 3 will be 33. And we have to modify the total sum with the node value, which is 3. So 33 will become 30. So this how we can modify till the end. Now, is this the more efficient approach that we are looking for? No. So there is another approach called we can change our traversal technique from left root right to right root and left. So how this will be efficient? So we will be looking into that. So how this process will be efficient? How this increases our space and time complexity? We will be uh, discussing about that. So you can clearly see that the last node's value will be last node itself, because the greater value than the last node doesn't exist, right? So it is nothing but the last node's value will be last node itself. If we take a variable total and initialize it to 0 at, at the start initially, so we'll be traversing right, then root, then left. So this will be our custom traversal technique to optimize the runtime and space complexity. So you can see that once we visited the right node, so you can add the node value to the tutor and manipulate the node. It is nothing but total equal to total plus node value. Then node value will become our total. 0 plus 8 equal to 8. So 8 remains our this node's creator sum. If we have to visit the root next, so what is the root node value? 7. So we have to add 7 to our total, which will be 15, and we will modify the node value. We will modify the node value. Then again we have to visit the left, but there is no left node, so we can simply go to the root node. So 15 plus 6 will be 21. 21 plus 5 will be 26. 26 plus 4 will be 30. 30 plus 3 will be 33. 33 plus 2 will be 35. 35 plus 6 will be 35 plus 1 will be 6. 36. 36 plus 0 will be 36. So this is the more efficient approach and takes less time and space complexity. I hope you understand the intuitions of the both the approaches. So let's look into the code exploration part. Okay guys, let's look into our first approach, which is DFS approach. So I clearly mentioned that we will be getting a total sum. So we have to traversal the tree completely and get our total sum. So this will be our code to get the total sum, which is nothing but first we have to get the right sum, left sum. Then we will be getting the right sum. Then we can return the current sum plus left sum and right sum. So hence after getting our total sum, we have to traversal the tree again, and we have to modify the node value. So as I clearly mentioned, the node value is nothing but node value plus the sum of all other elements which are greater than the current node. So it is nothing but the total sum. So this is the logic that this came up after the first intuition of our video. So you can clearly see the code. It is very easy to understand and read, and it is hence readable and maintainable also. So we have to traversal in a left, root, and right order. So we will be using DFS here. So in this part, what is our time complex? So we are traversing the tree one time, hence the time complexity will be big of n because we have to visit each and every node, and the space complexity will be big of h. H is nothing but the height of the tree. So this will be our time and space complexity, but you can see that the code complexity is very high because we have to first traversal and get the sum, and again then we have to traversal again and manipulate all the node values, which will be more not internally complexity, but externally you can feel the complexity of the code. Now we have come with another approach, which is right, root, and left. So let's look into that code. Okay, guys. Now let's look into our second approach, which is right, root, and left approach. So the code complexity, the time and space complexity is same because we will be traversing a node, and we have to maintain a space complexity of the big of h. H is nothing but the height of the tree. But the code complexity and the readability increases and the efficiency also increases. So we are creating a custom traversal function, and we will be visiting the right node first and modifying its values. So in the previously we have discussed the second approach, modification. So first we have to update our total sum with the node value. Then we have to update our node value with the total sum, which is nothing but the total sum equal to total sum plus node value. Node value will be the total sum. And again we have to traverse the left. I hope you understand the both intuitions and the approach videos. So solution is in my Discord profile. It will be published every day. Kindly check it. Thank you.